Here I'll discuss the topic probability. Let's have an introduction to probability. First of all, experimental or empirical probabilities. These probabilities are based on the results of an actual experiment. That is, we first perform the experiment a certain number of times and note down the outcomes, such as tossing a coin 1000 times and observing how many times head comes up and how many times tail comes up. Because on tossing a coin, there are two possible outcomes, one is head and the other is tail. Now, these probabilities are only estimates because if we perform the same experiment for another 1000 times, we may get different data giving different probability estimates. Okay. Now, let's look at theoretical approach of probability. It is not based on performing actual experiments. Suppose a coin is tossed at random. Now, a fair or unbiased coin means each outcome, that is head or tail, is as likely to occur as the other. That means the outcomes are equally likely. Okay, the outcomes are equally likely. Equally likely outcomes means that each outcome is as likely to occur as the other outcomes. Similarly, in case of throwing a die once, the possible outcomes are 1, 2, 3, 4, 5 and 6. These all are equally likely outcomes. That is, probability of getting 1 equals to probability of getting 2. Similarly, equals to probability of getting 6. So from now on, we will assume that all the experiments will have equally likely outcomes. Here, formula for experimental probability P of E equals to number of trials in which the event happened, okay, divided by total number of trials. So suppose if a coin is tossed 1000 times and head comes up 488 times, now our event is getting a head, so the probability of getting a head is equal to number of times in which head appeared, that is 488, divided by total number of times, okay, that is total number of trials, that is 1000. So probability of getting a head will be 488 by 1000. This is the formula for experimental or empirical probability. Okay, now the theoretical probability, also called as classical probability of an event E, written as P of E, is defined as number of outcomes favorable to the event E divided by total number of possible outcomes of that experiment. And here we assume that outcomes are equally likely. Now, sample space. Sample space is the set of all possible outcomes of an experiment. Suppose, take an example. On tossing a coin, there are two possible outcomes, head and tail. Okay, so number of total number of possible outcomes are 2. Now throwing a die, here total number of possible outcomes are 6. That is, die can show 1, either 2, 3, 4, 5 or 6. Okay, now event, the outcomes or a combination of outcomes is called an event. For example, in tossing a coin, getting a head is an event. Similarly, in rolling a dice, getting an even number is an event. Okay, getting 4 is an event. Now question, if a coin is tossed 2 times, so if a coin is tossed 2 times, then its sample space will be HH, HT, TH and TT. Okay, this first outcome means the coin shows head on both the times. Okay, here first time coin shows head, on second time coin shows tail. Here on first time coin shows tail, on second time coin shows head, and here coin shows tail on both the time. So the possible number of outcomes are 4. Now our event E is getting at least one tail. That means in the outcome there should be at least one tail and can be more than one tail. So we have to include those outcomes having one or two tails. So here favorable outcomes will be HT, TH and TT. So there are three favorable outcomes. Now, as the formula for theoretical probability states, probability equals to number of favorable outcomes divided by total number of outcomes. So probability will be equals to 3 by 4. Okay. Now an event having only one outcome of the experiment is called an elementary event. Okay. The sum of probabilities of all the elementary events of an experiment is 1. Suppose in tossing a coin, there are two elementary events, that is getting a head and getting a tail, and sum of probabilities of getting head and getting tail is 1 by 2 plus 1 by 2 equals to 1. Okay, consider another scenario where a die is thrown once. Now probability of getting a number greater than 4, and consider another event getting a number less than equals to 4. Now getting a number 4 means there are two possible outcomes, 5 or 6. So probability will be 2 by 6. And a number less than equals to 4 means getting 1, 2, 3 or 4. The probability will be 4 by 6 and their sum will be equals to 1. Also the elementary events in case of throwing a die is getting 1, 2, 3. That means probability of getting 1, getting 2 up to 6. These all probabilities will be equal to 1 by 6. And if we take sum of these probabilities, it will be equal to 1. Now complement of the event E, it is represented by E bar. It means not E. Okay, here suppose take an example. On throwing a dice once, suppose event E is getting an even number, so its complement will be not getting an even number. E bar means not E, so not getting an even number. Okay, here probability of getting even number will be 1 by 2. That means there are three possible cases, 2, 4 and 6. So 3 by 6 equals to 1 by 2. And probability of not getting an even number, is here there will be three cases which are not even, 1, 3 and 5, that is odd numbers. Okay, so probability is also equals to 3 by 6 equals to 1 by 2. So the sum of probability of an event plus its complement, that is probability of E bar, is always equals to 1. So probability of E bar is equal to 1 minus probability of E. Okay. Now impossible event. Such an event is impossible to occur. Now if this event is impossible to occur, so probability of impossible event is equal to 0. Take an example. Suppose on throwing a dice once, let E be the event getting a number greater than getting a number greater than 7 in a single throw of dice. Now the possible outcomes in a single throw of dice are 1, 2, 3, 4, 5 and 6. Okay, you all know the sample space 1, 2, 3, 4, 5, 6. So can we ever get a number greater than 6? Greater than 7? No. So probability of such an event will be equals to 0. Also we can't get a number greater than 6. So if the event would be getting a number greater than 6, then probability will be equals to 0. Now sure event. Such an event is sure or certain to occur. That means if this event is sure to occur, so probability of a sure event is equal to 1. Take the example of throwing a dice. Now here event E is getting a number less than 7 in a single throw of dice. Okay, suppose a dice is thrown once. Okay, now the possible outcomes are written here 1, 2, 3, 4, 5, 6. So in every case we always get a number less than 7. So this event is sure to occur, so its probability will be equals to 1. Okay, now in general case the probability of an event is greater than equals to 0 but less than equal to 1. So probability always lies between 0 and 1. So minimum value of probability can be 0 and maximum value can be